Chapter 7, Transverse Shear Nail Spacing, example number 1. This example, we have a configuration which consists of three boards, 1, 2, 3, and they are attached to each other by these nails. If the vertical shear of 800 pounds applies and the capacity of strength of each of these nails is 100 pounds, we want to know what is the distance between each of these nails. So let's approach this problem. The equation for this kind of problem is the number of nails times the force of the number of nails times the force of nails, and then that's equal to shear flow times first moment of the area over moment of inertia uh, first moment of area, which is Q is A prime times Y bar prime, and V is shearing force of nail is the capacity of each nail, which is provided here, and shear is also 800 pounds based on our problem statement. So we want to know what is the distances between each of these nails in terms of a numeric value of 10 inches, 5 inches, something like that. So in that equation, if you get it, the first part we need to know is the centroid. What is the centroid to calculate the I and also the first moment of area, which is Q. So first of all, we need to calculate the centroid of the whole configuration, and if you do so, it just says it should be somewhere between the centroid of each of those parts individually, and the dimension of each box is 10 inches by 1 inch, and then y bar is equal to a summation of ai times yi over summation of the area, and if you do the mass, it gives you 10 times 1, which is here, times 9.1, which is the centroid of this part, to base, which is we start from here, that's 9.5 plus 2 of these guys over the area total, which is 3 inches, 30 inches squared, and that gives us 6.5 inches in terms of value for y. That's our new value for y bar, centroid of the system. And in moment of inertia then would be by applying the parallel axis theorem. I is the green part over here, which is related to the top part, 112 base cube height, 11210 times, cut it through here, that's 1 cube plus a d squared, that's a times d squared, a is area is 10 inches squared times the centroid of this part to this total entire system centroid. So that's a 5 inches distance from these two centroids. That's the distance between the centroid of the top part, the centroid of the entire system, and that's a 3.5 inches. And also of 2 of these guys, which is a 112 base cube height, and then this time 10 cube plus AD squared, this time AD squared, A again is 10 inches squared, and D is the centroid of this part, which is 5 inches from 6 mile, that's 1.5 inches distance between the centroid of the entire system to the centroid of each of these legs. If you do the mass, it just gives us I moment of inertia of the system is equal to 335 into the force. And if we replace that in our transverse shear equation, it just gives us the results. So for example, if we want to see the effect of shearing, if we cut this part, like we separate it, and it just and observe the effect of shear only on this leg. So it just says number of nails times the force of nails, which is 100, is equal to V, which is provided to be 800 pounds, times Q over I, which is we calculated it, that's 335 inch to the force. Forget about the unit for now. And now we need to calculate Q. So if you look at the configuration here, it just gives us for one nail, if we want to calculate, this is dx, and if we want to calculate dm over x, that's the shear fluid. V is the derivation of moment over distance. So it just says we just want our shear for the unit of length. So forget about the rest. We are just talking about one unit of length, and that's a 800 over I, which is 335, and our area is this part. Our area is this part. So that's as you can simply see the configuration for that part of area. We just need one of the nails. So that's the number of one. Just comes from there. And Q also is a prime times y bar prime, which is a prime is 10 times 1, which is the area of this. The blue dashed area is a prime times 1.5, which is the centroid of this part to the centroid of the entire system, which was something like 6.5, and this is 5. So a distance of 1.5 is the distance of these two centroids. And if you replace it in the equation, so everything is now obvious. Number of nail for the unit length is 1 times the capacity of each of them is equal to shear force over the moment of inertia times Q times the distance. And if you do the mass, it just gives you the numeric value of 2.79 inches is the spacing between each of these nails to the board. So it means if there is a stress due to bending and it wants to separate these plates from each other, it just needs a distance of, we need to locate our nails in a distance of almost 3 inches apart from each other to stand the total length, whatever the length is, because our calculation is for the unit of the length. And you can also solve this problem. So for example, you can cut the problem through from here and see the effect on each of these legs, and likewise what we did right now. And also you can separate the top part. So if you just take this part out of the and see the effect of, so it means if we want to apply a stress, push it all the way to the board and separate the top part from the two legs. And if you look closer to the problem, you can easily see this is our A prime this time, this is our A prime this time, and it just says for the top part, for the unit area, which is A prime, again 10 times 1, that's 10 inches squared. And you can easily see now they are two of the nails, which if you want to apply if you want to push it to the board, there are two nails at the unit of length which holds the top part. So that's the number So you can go for each of the parts. So you can observe it for a leg, one of the legs. So if you just separate the legs from the top part and you need to go for this area and use one of the nails or the other one. Use this area or one of the nails, or the other part is just go with the top part and consider the two nails which hold the top part. Because for the legs, just one of them is holding the structure, and the result for both of them are equal to each other. So two of them times the capacity of each of the nails is 100 pounds, and V is provided. We need to calculate the correct Q this time over 334, if I'm not wrong, times the distances, nailing distance. So if you do so, it just gives you a separation like this again. This is our cross-sectional area, and two of the beams are holding, two of the nails are holding the top part. So it just says this time the number is 2 because again two of them are holding our structure, one at the left side, the other at the right side, and this is our area. Q remains the same, capacity of nails remains the same, moment of inertia for the entire system remains the same, but Q, first moment of the area, is changing because A prime is for this part, which is also equal to the legs, but that's just by random. Then times Y bar prime, which is the distance of the centroid of the top part to the centroid of entire system, which is a 0.5 inches. And if you replace that, it just gives you a distance between the nails, which is equal to the previous part, and that's again just gives us, if we want to locate in the entire length, whatever your length is, have to locate the nails by the spacing of 2.79 inches. So all the nailing problems is to work with the appropriate area for calculation of first moment of area. Thank you. We'll solve more problems in transverse shear in nails.